Hello everyone and welcome back. Today is day 34 of our journey into low-level design. In today's session, we will tackle a very important real-world component building a complete logger framework. Logging is a critical backbone of any serious application and designing a clean, extensible logger gives us an edge in writing maintainable systems and acing interviews. Get ready, today's session is going to blend everything we have learned so far into a beautiful practical design. Let's set our expectations for today. First, we will understand the core requirements of a logger system. We will then design a flexible framework that can support different types of outputs like printing logs to the console or writing them into a file. We will make sure it supports various log levels like debug, info, warning, error, and fatal. We will learn how to build it in a thread-safe manner, which is crucial in multi-threaded applications. On top of that, we will make our logger extensible and configurable so that adding new features in the future is easy and seamless. Finally, we will briefly touch on advanced features like buffered logging, where logs are stored temporarily for better performance. By the end of the session, you will feel ready to implement your own logger from scratch confidently. Let's think for a moment. Imagine you are building an e-commerce app or a cab booking app. Bugs will happen, users will face errors, unexpected states will occur, and if you don't have proper logging, troubleshooting becomes a nightmare. A robust logger is your first line of defense against unknowns, but it's not enough to just print things to the console. You need structured, controlled, and reliable logging that can scale your application, and it has to handle real world challenges like concurrency, performance, and multiple output destinations. That's the exact problem we are solving today. We want a logger that's simple enough to use but powerful enough to grow with our application. Let's be very clear about the requirements. Our logger must support different levels of logs such as debug, info, warning, error, and fatal. It should be configurable, meaning users should easily choose whether logs go to the console, a file, or both. The logger must be singleton, meaning only one instance exists during the lifetime of the application. It must be thread safe because in multi-threaded environments, multiple parts of the system might log at the same time. Finally, our design must be extensible. Tomorrow, if you need to send logs over a network or save them in a database, you should be able to do that with minimal changes. An optional but powerful feature is buffered logging, where you temporarily store logs in memory and write them in batches for performance gains. This gives us a comprehensive production-ready feature set to target today. Now let's zoom out and look at the big picture. At the heart of our design, we have the logger class, built as a singleton responsible for managing the logging flow. The log manager will act as a bridge between logger and actual writers. It will take the validated message from the logger and decide where it should go. We introduce an interface, log writer, which defines a simple write method. Different implementations like console writer and file writer will implement this interface to handle writing logs to different destinations. Each log entry itself will be represented as a log message object encapsulating all details like the timestamp, log level, and actual message. With this structure, notice that every class has a single responsibility. Logger focuses on orchestrating logging, writers focus on outputting logs, and log manager coordinates the process. This separation keeps the system clean, testable, and extensible. Our logger is built on solid design patterns, no pun intended. First, we use the singleton pattern to ensure there's only one logger instance. This is important because if multiple instances existed, logs could become messy, inconsistent, and even lost. Next, we use the strategy pattern via log writer, letting the system choose at runtime where to send the logs, console, file, or even a future database. We follow the interface segregation principle, ensuring small, focused interfaces. We also abide by the open-closed principle. Our system is open for extension but closed for modification. Meaning if tomorrow you want a new kind of writer, like an email writer, you just create a new class without touching existing code. And finally, we make sure everything is thread safe to avoid corrupted or lost logs in concurrent environments. In all-in-one, our logger system becomes a textbook example of good design practices in action. Let's visualize the process. A client, let's say a booking service, needs to log an event. It calls the logger's log method. The logger first checks if the log level is valid and whether it needs to be logged based on configuration. It then wraps the message into a log message object, adding metadata like timestamp and level. The logger passes this log message to the log manager. Log manager then sends it to all configured log writers. Maybe one writes it to the console and another writes it to a file. Notice how beautifully decoupled the client is from the actual log handling. It simply says log this and the framework takes care of everything behind the scenes. Let's peek into the core class logger. It uses a private static instance and a private constructor to enforce the singleton property. It exposes a public static method get instance to provide access to the one and only one logger object. The log method handles incoming messages. It validates them, wraps them in a log message object, and passes them to log manager. Notice that logger does not concern itself with how or where the log is written. It delegates that responsibility, which keeps it focused and simple. Also, synchronization mechanisms ensure thread safety so that multiple threads can log safely without collisions. At the heart of extensibility is the log writer interface. It defines a single, elegant contract, the write method, which accepts a log message. Any class that wants to become a log writer, be it a console, file, or network destination, simply needs to implement this interface. This follows the dependency inversion principle beautifully. High-level modules like logger depend on abstractions, not concrete implementations, which means you can add new writers anytime without touching or risking existing code. Here's an example of a concrete log writer, console writer. It implements the write method and simply prints the formatted log message to the system console. Simple, clean, and easy to test. A file writer would look very similar, except instead of printing to console, it would append the log entry to a designated file. By adhering to the log writer interface, different writers remain pluggable and interchangeable. Tomorrow, if your client says now send critical logs to email, you can add an email writer without modifying a single line inside the logger or log manager. That's the power of clean design. Want to make sure your logger truly world class? You can introduce asynchronous logging where logs are queued and written in a background thread, boosting application performance dramatically. Implement log rotation where after a file reaches a certain size, a new log file is automatically created. Support multiple appenders where the same log is sent to multiple outputs simultaneously. Make the logger configurable at runtime by reading from external configs files like JSON, YAML, or properties files. These features are not must-haves for today, but thinking about them pushes you toward building production-grade systems. Always remember, good design isn't about cramping features, it's about building a strong foundation that can gracefully grow. Now it's your turn to build. Create a basic console logger that follows the singleton pattern. Extend it to also support writing to a file and log levels so that the user can control what gets logged. Ensure the logger is thread safe so that we don't run into issues when multiple threads try to log at once. And if you feel adventurous, try adding buffered logging where logs are temporarily stored in memory before being flashed to disk. This assignment is incredibly valuable because once you build this yourself, you will feel a huge leap in your confidence as an LLD designer. By the end of today, you will have something amazing in your hand, a fully functional logger framework designed thoughtfully, implemented cleanly, and ready to scale. More importantly, you will see how solid principles, design patterns, and clean code come together to solve real-world problems elegantly. The skills you gained here aren't just about logging, they are transferable to every system you will design in your career. Congratulations in advance. Today's session is a massive milestone, and thank you for your attention.